Now, hello and welcome to a next installment of cybersecurity workshops with Q Project. Um, this cybersecurity workshop series is called Pocket Edition, and today we're going to be talking about security processors. So, in modern security, there are basically two different um, ways to tackle security. On one side is the actual communication based between multiple computers and how computers actually process stuff. On the other side, there's also a way to basically crack the actual OS. So, how the processors actually work, that decrypting that and breaking that by finding bugs and getting the sensitive information out. That's another portion of modern security. So, why security processors? So, um, in what I mentioned before, there's no physical hardware support for doing modern security. Like all the penetration testing is all software based, and there's no like penetration testing for actual hardware. And so, we have to design these special processors that are designed just for security. They add an extra layer of security that usually is used for basic uh, or beyond basic storage encryption and basic security measures. This is to provide end-to-end encrypted security just for your system, your personal computer. Also, many modern CPUs have a binary privilege escalation. So when you run a program, there are two ways or two a binary um, choice of whether that program has privilege escalation to access your hardware or not. It's either one or zero. And this is good to some degree, is that some you don't want some processors such as like clean my mac to actually destroy your actual hardware or destroy or write some malware or something. For example, you don't want zoom to do that as well, so their privilege escalation would be like zero depending on the type of process and threads, of course. And so with security processors, there's multiple layers rather than just a binary privilege, because the problem with binary is that what if two programs are using the same privilege, highly privileged usage of a hardware? So sometimes they can overwrite each other and they can probably affect one another, allowing for one program to have access to stuff that the other program should have. And then there are many issues that arise from there. Also, another thing is that security processors are a dedicated separate piece of hardware. They are separately designed specifically for security, and they're separate from your CPUs. For example, the Apple T2 chip. And so you might be wondering what do these security processors do exactly? What's the end goal? So in the Apple support documentation, they basically listed this description of the T2 chip. So in general, it secures all the authentication data, such as Touch ID data, and says here, FaceTime HD camera in your iPhones. So it stores all the authentication data that allows you to get inside the actual Mac. So if that was unencrypted with just um, basic storage encryption that you could just easily decrypt, then it'll be really, really easy to actually break into your Mac. And I'm going to mention a little bit later how you can actually easily break into it because of a massive security flaw in the hardware of the Apple II chip. I'll go over that a little bit later. So, why security processors? Just a continued slide from before. Some reasons to have these. Uh, just a simple paranoia of just being paranoid of security. There's also, this falls into the whole zero trust category, where there's this whole movement going on right now where you or people have zero trust for big companies such as Google's, also just zero trust in general. Whenever you visit a website, you give zero trust to anything that's technology wise, and you just want to protect yourself from there. That this is a entirely whole discussion. There's even like courts going after big trust companies. um, if you're building something, building an application or doing some special design of the newest Apple iPhone, you kind of want uh, you kind of want people not to look at them, right? So you want to protect the designs by encrypting them, especially with the security processors. It protects IP as well, which is intellectual property. You also want to protect sensitive data, maybe perhaps of trade secrets, business plans, and HIPAA, basically other medical data. Also, passwords. You don't want people to steal your passwords or risk other authentication data such as Touch ID and Face ID. You also want to maybe protect legally liable data. So what I mentioned before was the HIPAA medical data. So basically, this act, it was put out to protect users or just protect people from hospitals just releasing their medical data. And so that's pretty classified. Just any other classified information should be secured with these security processors. So some characteristics of a security processor include some kind of anti-tamper or intrusion detection system. So if my Mac is turned off and I go inside and I give power to the hardware to actually read it and stuff, you would notice that, oh, this is being plugged in, or the voltage is not right, or they're not sending the correct security bits. And they would know that the that the hardware is being tampered with, and so it would probably delete the data or do something of that sort. You also want to execute secured programs, or also known as just encrypted programs. This is good for um, just when you're running a very special enterprise level software to communicate with with um, your colleagues at work. This is for like trade secrets. You also want to protect any data or code from any unauthorized access. For example, if you have special data or your applications or IP or designs on your computer, you don't want someone else to steal your computer and then just easily read it by plugging in the hard drive. That's what the whole purpose of encrypting it with the security processor does. You also want to secure the I/O communications channel. So I/O stands for output. And so how it works is where a CPU, when a program wants to write to the hard drive or write to the memory, it uses an I/O communication channel. And so you want to secure that by encrypting everything from end to end. Sometimes there's also some unsecurable I/O communication streams. For example, for like some programs, they might ask for, you can't encrypt this, just send it there. It's too much to encrypt. It's too much processing power, and I kind of need it now in the RAM. And so you want to isolate this from the actual rest of the laptop so it doesn't get corrupted. You also want high reliability. So what's the purpose of a security processor is to secure data, but if it's not reliable, then how are you supposed to secure it? You want to limit the number of routine failures in this processor. And of course, this security processor, also known as crypto processor, because you are encrypting the data, you need a very high performance processor. And sometimes it uses different power settings or acceleration to finish this. Yeah, encryption or and other processes similar to encryption like cryptography are very expensive operations you want to actually perform, and that's why you need high performance. So what are the goals of a security processor? You want to give access to hardware and authentication, and you want to keep these keys secured, and you want to delete these keys when they're under attack. And they use this term, or this term called zeroed, where basically data is stored in ones and zeros in your hard drive, and these authentication keys and hardware keys that give you access to the hardware they're zeroed, meaning all of the bits are turned into zero, which basically allows all your data to be, all your keys to be lost, which protects your hardware, because if you're trying to get in, you need to send an authentication key so that it doesn't um, detect the anti-tamper or the or the intrusion detection software in the hardware. Also, you want to encrypt whenever possible. You should encrypt the data before it's stored in the main RAM. For example, if you're on a CPU and the processor is saying, okay, go store this in the RAM over there. Okay, so you want to encrypt this data in the flight so that when you're sending it to RAM, no other users can see it. Because when you open your laptop, you can see that the RAM and CPU, they're not actually connected. They're just connected through a wire. And so if someone was able to get access of that wire, they will be able to read the zeros and ones and basically decrypt the data from there. So you want to encrypt it. You should also encrypt the addresses where the data is temporarily stored. This goes into the computer organization class on campus. This is where in the CPU, when you're processing data, sometimes you want to just create a small little cache inside, and they're stored in address spaces, and you want to encrypt those as well in case if, of course, any intrusion happens. And of course, isolate those insecure channels what we were talking about before, such as the IO insecure communication channel. Now, I want to talk about a specific class of security processors because there are many different classes. It's called System on a Chip, SOC. You may have heard of this a long time ago or whatever. Basically, it's pretty SOC is stands for System on a Chip, and it's really effective for implementing secure embedded systems. And what it is basically an entire computer system on a single piece of hardware. And the reason why this is effective is because since it's on one piece of hardware, it's able to be packaged and protected as just one single unit. For example, this is like one entire unit, this black box. So you have um, a processor right here. You got RAM, you got different CPU cores, you got storage, all that into one small little piece of hardware. This is known as a SOC, and the security processor would process all the security measures, all the encryption inside here using its own RAM, its own storage, its own addresses and data through just in this one encrypted black box, which other intruders may not be able to get into. Well, theoretically, not be able to get into. Of course, we'll see some other poor designs of these security processors, which can eventually lead to dire consequences and your laptop being hacked, or that security processor being hacked, which leads to loss of data, which leads you to loss of passwords, which leads to laptops being stolen, and because they have their passwords, they can basically decrypt the entire hard drive. There's this flaw in the Intel processor that came out, and this came out around May 2019, and it affects all Intel processors since 2011. This is known as the zombie load attack. So how it works is it targeted the flawed design in Intel CPUs. It sends unprocessable data to the CPU, purposely making it crash. So when a CPU crashes, it sends data to that application to further process. So, for example, the app might say, okay, this user clicked on submit info or just save info, and then it didn't work. And then the CPU sends the info back to the app saying, oh, it didn't work because of this. And then the apps can work on from there. So when the CPU is sending it back to the app, that part was not encrypted, and that's why the this attack works, is because since that was not encrypted, you can actually take that data out. And since debug info is pretty valuable when you're working with directly with processors, you're able to just get all the information and probably use it in some kind of malicious way. As to secure this, the data should be in an encrypted box when you're sending it to the application for debugging processes, or you can just simply encrypt the data and decrypt it at the application level. Now, the Apple Security T2 chip. This data is actually recently new and it just came out. So you can probably see it in the news if you look it up. You can just look up Apple Security T2 chip vulnerability, and this news is that news articles came out just a couple days ago, a day ago. So according to Iron Peak, um, they say that Apple left a debugging interface open in the T2 security chip, shipping to customers, allowing anyone to enter device firmware update mode without authentication. So with this security chip being flawed, users are able to um, put the chip into developing mode and actually change the code of the security chip. And this is because, again, through the debugging interface, similar to what we saw with the Intel, somewhat similar to what we saw in Intel. So this is just goes to say that encryption is a need everywhere, especially in the debugging kind of world, because that's where valuable data is stored, and that's where hackers go to look at what kind of information or what kind of exploits they can use to target the holes in your software or in the OS. And a good thing for your ordinary users is that the attacker needs direct physical access to the Apple device in order to exploit it, because you need to restart your Mac and then actually upload the code to your T2 security chip. And this is the reason why there are many stolen devices out there, because of this vulnerability that allows you to actually overwrite your entire OS and just rebuild it from the top up, down up. So why should you care about this? So CPU, it should have hardware rooted trust, because you want it to actually process your stuff and give you good results and actually do what it's supposed to do. And it should be allowed to process information without anything getting leaked through the use of various security techniques like the security processor. And this is specifically important for cloud security. So if you could just imagine all the data that's stored in the cloud, and just imagine it all being leaked. So all your photos, videos on the iCloud or in um, your box folder, all that, all those answers to the midterms, they're all leaked online. That's that's going to be pretty bad. So we want to be able to use the CPU without having to actually um, worry too much about security, and that's what this entire workshop series is about: is to basically tackle that security um, cloud and see how we can actually secure these without having to actually have the end users worry about that as much as they should right now. This is my works cited, including image links. So my presentation is done here. Does anyone have any questions? I see we had a question here. Is this something that can be fixed with the software or firmware update? No, this cannot be, because this is the actual hardware issue. And so many of these flaws, especially the Intel one and the T2 one, this it's built into the hardware, like um, it's actually soldered on the wires, and because you can't unsolder them, encrypt them, and then put them back, that it doesn't work that way. And so it's all um, hardware related. So in order to get a fixed secure computer, you need to get an actual different security processor, or a different this entirely different computer. Also, although there are some security patches that have been made for previous exploits, but of course none of them actually work, or none of them actually solve the root of the problem. Does anyone have any other questions?
I was going to say another thing to note is the T2 chip came out in 2017, so it's only 3 years old, and they've already broke it. So that's scary to think about. All of the new Macs and iPhones from 2017 and on have this vulnerability in it now.
Yeah, that's true. In fact, the Cydia, the creator of Cydia, the jailbreak software, if you know what I'm talking about, they created something for Mac as well. I think I have the link right here. Uh, Let me share my screen quick. So this is the same people who, the same team of hackers who actually jailbroke the iPhone, and their iPhone just came out with the new release, iOS 14. And because of the T2 chip security vulnerability, it was already jailbroken as soon as it came out. Just a couple more weeks, and bam, that's it. They even have a download from Mac OS, which um, turned out, well, I haven't done it, but it just recently came out because of the T2 chip. Um, if I go through the one person's Twitter feed, he actually put Linux on the touch bar of the Mac right here. So you can see just code. I'm not sure if you can decipher that, but that's what it is. So definitely check that out. See how does it work, because I found that pretty good. They're also saying in the comments you should play Doom on the touch bar, so I thought it was pretty funny. Basically, for those who don't know jailbreaking, I should have mentioned this before. Jailbreaking basically allows you to circumvent or to remove your entire OS from your laptop or phone, and to put a very specific OS that allows you to actually touch the hardware, metaphorically speaking, with code, and to actually manipulate the hardware directly instead of going through an OS, because the regular iPhone OS limits what you can do with it. Of course, because there are privacy concerns and everything, you don't want an app downloading all your hardware data and sending it to someone else. But with a jailbroken app, you can do that. Of course, do this at your own risk, because it can definitely not harm yourself, but it leaves you vulnerable in some ways to attacks. So, of course, watch out for that.
I used to jailbreak my iPhone for years, and there's definitely security risks with it. But if you know how to protect yourself, the main ones are just that a jailbreak on an iPhone or an iPad gives you root privilege. So you probably use the Files app. The Files app doesn't allow you to see every file that the iPhone's running. Once you jailbreak, you can download a legit file app that lets you see all your root files, everything, And so one of the cool things I used to do was I would go into the, if you go into settings where your wallpapers are, I could go into the Files app, access the wallpapers folder, and put my own images so that whenever I would go to my settings to choose a wallpaper, I would have custom wallpapers in my settings app. So it's like you could do stuff like that, as well as you could SSH from a computer to your phone and edit your actual phone's root directories, which is what the danger is. You don't want someone SSHing into your phone and having full access to everything. And that's why people say jailbreaking's bad, but you just have to know how to protect yourself.
Of course. Are there any extra security measures you took after you downloaded or you jailbroke your iPhone?
Not really.
Not really.
You
Yeah.
just you can turn SSHing off so that people can't access your phone, but the best thing about it is that you have root access. So Cydia, like you're mentioning, is basically just a app store that instead of downloading apps, you're downloading tweaks or configurations or files that people have created, installing into your root file system that you have access to now, and then it allows you to change stuff. So if you guys think about night mode on iPhone and widgets on iPhone that just came out, all this new cool stuff, I was using it back in like 2013 because people had already created apps and tweaks for it. But Apple slowly steals all those jailbreaking ideas. And so nowadays it's not as fun to use anymore because Apple has most of the tweaks that were cool to use.
Yeah, I remember one tweak. Back then, the Apple Watches, I think they still have it now. I'm not sure. I don't have an Apple Watch. Basically, they had all the apps in a small circle in just a kind of space like fashion where all the circles were nearby each other. And when you were moving around, you were basically moving around this globe with all different apps around it. And so which was good for the Apple Watch because for HCI, human computer interaction, you're able to like look around and you're able to keep going around like an infinite scroll kind of simulation. You were able to do the same thing on the iPhone. I remember one of my friend in high school did it a long time ago. He was able to simulate the entire Apple Watch interface on the actual iPhone. Also, a couple things you can do with the iPhone. Like after you jailbreak it, you can run so much different stuff. You can run Linux, Kali Linux, and with these workshops where we teach you, you can probably do lots of different stuff. Like for example, one workshop we did was the authentication of different people. So you can have your phone run deauthentication code to send deauthentication packets everywhere so that you can just log people off wherever you are. I think that would be pretty hilarious. I might cover that a little bit on another workshop as well. So stay tuned. So if anyone has any more questions, I'm going to stop the recording